Testing 1 2 3. Testing 1 2 3. Alright. Said I was having some issues, but it looks like everything is working properly. Well, as we wind down here, we're in Chapter 63, talking about vehicle rescue and rescue awareness operations. And much of this might have to do with perhaps a fire department or a dedicated rescue squad, more so than with a paramedic rolling on an ambulance. Typically on an ambulance we have limited rescue equipment, but rescue is defined as the act of delivery from danger or entrapment. The role of the paramedic is to locate the endangered persons, remove them from danger, treat their injuries, and transport them. It does require a certain degree of medical and technical skills, specifically for rescue. Medical care and rescue simultaneous actions that occur is you're going to be in the ambulance. You may arrive on scene. The patient may need heavy extrication to get them out of their vehicle. You may be in the vehicle with the patients while you coordinate your care with the rescue efforts that are being done by the fire department or the rescue agency. You're going to have to gain access to your patient and assess your patient. You may even have to provide treatment during the extrication before the patient is released. And then once the patient is released from entrapment, reassess, transport, and treat en route. I think it's important that as a paramedic you must be aware of the awareness of the situation and understand what hazards that you may be dealing with. Hazards may include things like airbags that have not deployed, leaky fuel, the potential for fire or explosion, and in addition to having an awareness of the situation, that includes knowing when the scene is safe. If the scene is safe, you certainly can access it. If it isn't safe, like a down power line across the vehicle, then that certainly isn't a situation that you want to approach until you know the power is off from that line. And then once it's safe to access the patient, having the skills in order to do that is part of your training as well. Awareness is the minimum capability for responders who could be first on scene. You remain in a safe zone. Rescuers will bring the patient to the provider, and this is very similar to the hazmat awareness, where you kept your distance from the scene and people with hazmat training would go in and bring you the patient. Operations, that is the ability to recognize these hazards as well as use the equipment necessary for rescue, whether it be the spreaders or cutters or airbags or any of these other pieces of equipment that might be used in a rescue situation. Technician, those are the highest trained folks on scene and certainly have the knowledge to know how to identify the hazard, how all the equipment works, and how to coordinate and supervise the team during a rescue situation. We've always been taught scene safety. That's the first thing we look at before entering a scene, making sure that you're safe, making sure your team is safe, making sure the bystanders or other uninvolved persons are safe as well, and then carrying out the rescue in a safe manner. In the incident command system, part of the command staff would include a safety officer. And the responsibility of the safety officer is to make sure that the rescue operations that are being carried out are being carried out in a safe manner. When you arrive on scene, if you're the first one to arrive on scene, you're going to establish incident command and establish priorities. What do we treat first, second, third? Where do we stage? Where are we going to set up triage? Where we're going to do all these things? and then keep in mind the safety for incoming responders and patients when they start being brought to a treatment area. When we talk about setting up incident command, we all know the fire chief is the incident commander, has the overall authority of managing that particular scene. But as a medical commander, you can set up medical incident command and appoint people to positions like triage officer, a transportation officer, staging officer, positions that would be necessary in order to manage a larger event. You want to determine the number of patients and begin triage. If there are multiple patients, then we triage using start and jump start. If it's a single patient, we're going to do an assessment and determine which of their injuries requires immediate attention and approach those first. So if I arrive on scene and I've got a patient who has exsanguinating hemorrhage and maybe some broken bones and some other problems, burns or whatever, inhalation injury, I've got to prioritize which thing I'm going to take care of first. And most of us have been taught the ABCs. We take care of the airway first, and then the breathing, and then the circulation. But in certain situations, circulation may be first, like with that exsanguinating hemorrhage. Now, search and rescue versus recovery depends on the individual situation. But if it is suspected that the patient is dead, then it becomes a recovery, and the urgency diminishes. I'm sure people that are doing the body recovery are trying to, as quickly as they can, find that body so that the loved ones can begin closure with that. A good example is a drowning. In most drowning operations, if the patient has been underwater less than an hour, it's considered a rescue. But if the patient's been underwater greater than an hour, it's considered a recovery. There has to be some sort of risk versus benefit analysis done as well, because decisions have to be made about how you're going to approach each individual scene and each individual rescue operation. And so you have to weigh, if I'm going to choose to use these particular tools for this particular type of extrication, what are the dangers of using these tools under these circumstances? And make certain that we mitigate, a term that's often used to describe managing an operation with the least amount of casualties. And then also, as you're doing a scene size up, determine the need for additional resources. Do I need anybody else? It's better to call for them sooner than later. Command and control. Command is just that. Establishing the incident command system and who's in charge. Control is taking over the scene, establishing immediate priorities, setting up hot zones, warm zones, cold zones, implementing your incident action plan for a major disaster. The time to access and evacuate is a report that's provided to the incident commander. And what they mean by that particular bullet point is that during a major event, and we're talking a major grinder or a major building collapse or explosion in a school or something like that, that we're going to have operational periods. And we're going to have priorities that we need to accomplish in that first operational period, which is designated by the incident commander. And that could be a 1 hour operational period, or 2 hour operational period, or a half-hour operational period, where the priority is to determine the number of people we have and what sort of injuries do they have. And that's something you might determine in the first operational period. And then how you might triage them, transport them, get them out of there might be something you report back in the second operational period. As far as hazard control goes during a rescue operation, the first arriving person identifies the hazards or attempts to identify what the hazardous material is and to make the scene safe. We use a term called situational awareness, and uh, that refers to the emergency responder's ability to maintain accurate perception of the external environment and to identify the source and the nature of problems, as well as to detect situations requiring action. Situational awareness, factors that diminish situational awareness include insufficient communication. Nothing will destroy a hazardous response faster than insufficient communication. Fatigue and stress, task overload, task underload or boredom, the group mindset, the philosophy of press on regardless, degrading operating conditions, changes in weather, rapidly changing and unplanned operational conditions as well, referring to changes in weather. Some ways to prevent loss of situational awareness is to actively question and evaluate the progress of your mission, analyze your own individual situation, update and revise your image of the mission to your incident commander, and use assertive behavior when necessary. Determining the best way to access the patient is, of course, the first point in gaining access. You need to decide what's the best way I'm going to be able to access this patient and determine what their problem is. It may require stabilization prior to extrication, so you may have to medically stabilize them before you can move them, physically stabilize them before you can move them, and this continues through your transport. Medical treatment starts at the first contact all the way through definitive care. We're going to do our rapid primary survey or rapid primary assessment to identify life threats, particularly with airway, breathing, the potential for C-spine immobilization. The need for IV fluid therapy has become much less of an emphasis, and that if a person does require IVs, they're done en route with small amounts of fluid. If you're dealing with a longer rescue, a trench rescue, for example, or an entrapment, where you're looking at hours to get people out of the situation that they're in, we may have to pump warm air into the trench to keep them warm. We may have to bring them food or give them IV fluids with some sort of sugar or electrolytes in order to keep that stuff all in check. They're probably going to have to go to the bathroom and may have to wet or defecate in their own clothing while waiting extrication. Disentanglement is releasing the patient from the physical entrapment. It's driven by the patient's needs, and you have to take into account both the rescue and the patient's safety, especially if you're trying to disentangle somebody from around a steering column or foot pedals in a vehicle where the airbag has not deployed. Patient packaging, that requires us to determine how we're going to package the patient for transport. Also keeping in mind how to secure the patient to prevent from further injury during transport. Transport and evacuation deals with what vehicles I'm going to use, how I'm going to get the patients to where, and decide whether we need to do things like scene flights or take them to the hospital and then fly them out, or take them by ground directly to a trauma center. Some personal protective equipment that you as a rescuer might need to be familiar with include gloves, waterless hand cleaner. Personal protection from bloodborne pathogens are very important in rescue situations. Helmets, there are no real standards for helmets in this sort of situation. but they do make helmets designed specifically for high-angle rescuer as opposed to helmets that might be designed for water rescue. Eye protection, again at a rescue scene you may be dealing with falling or flying debris, dust and metal particles, smoke and noxious gases or chemicals, bloodborne pathogens that could spray into the mucous membranes of your eyes. Ordinary prescription glasses just don't provide enough protection. Hearing protection, that would be having earplugs and earmuffs available to you for really loud rescue situations. Hand protection, your inside exam gloves and then your outside work gloves, and you may have gloves specifically designed just for cleaning. Foot protection, boots, high ankle support. EMS is no place for sandals, soft-toed shoes, open-toed shoes, any of those things. It's just not a place for it. Clothing must provide protection from blood and body fluids, must be resistant to chemicals, must be resistant to wind and rain, must be of high visibility, must be resistant to tearing and cutting, and the ability to wick sweat away from the skin as well. The different types of personal protective equipment as far as clothing goes. Fire and flight operations are going to have Nomex suits that are designed specifically for fire retardation and being able to be in hot environments and have the clothing not start fire. Highway operations, we're talking about your very high visibility vest that you have to wear now, and then cold weather clothing when you're dealing with cold weather. Personal flotation devices must meet the Coast Guard standards for flotation. Type 3 is preferred, which is an actual vest or a jacket that has the built-in flotation devices. Airbags are something that we should be concerned about when doing vehicle and crash rescue extrication. You can have frontal airbags, side impact airbags, knee bags, and what is important about airbags is if I arrive on scene of a motor vehicle collision and none of them have deployed, there's always that potential that they could deploy during the rescue operation. So here's just a picture of some side curtain airbags, some knee airbags, and some airbags coming out of the dash and the steering wheel. This too is the same, where we've got some, looks like the roof has been peeled back, and we've got a deployment of the passenger and driver's airbag. When airbags do deploy, they do put some dust, it's usually talc powder, in the air, which may be irritant to some people. So the dust or something that may occur as a result of deployment of an airbag, people just need to be aware that it's just that. It's just talc powder and shouldn't pose any sort of anaphylactic reaction or that sort of thing. Just trying to look here. What they're trying to show is some airbags can be turned off. So you may get deployment only on one side of the vehicle. When you're dealing with a vehicle crash extrication, the first thing we need to do on arrival, have the patient remain still, gain access, scroll down the electrical windows, the electrical doors, and give the electricity not give the electricity, remove the keys and put the keys on the dash or somewhere where they can be seen or accessed. But only after you unlock the doors, roll the windows down, move the power seats back, unlock and release the hood, the trunk, the hatchback, or the tailgate, move the gear selector into the park position. Then we turn the ignition off, put the key up on the dash, and cut the battery cables with a negative first. And here what they're showing is cutting a piece out of the negative cable, rather than trying to just unscrew the negative cable from the post. Just cut a chunk out of there so that they can't touch each other and potentially cause a spark. Look around for indications that there are side airbags, knee airbags, pillar airbags. We're looking for the ABS, which would be looking for a tag like on the seat that says airbag, and we're looking at a tag that says SRS, which would indicate an airbag as well. As far as extrication, an undeployed airbag is present. Avoid unintentionally powering the electrical firing circuit. May cause the propellant to react by mechanical force and expose to heat, spark, and static electricity. Don't puncture or cut into high-pressure cylinders of stored gas in the airbag system. Don't put yourself between the patient and the airbag. And strip the cord before cutting. Okay. Here's just a picture of an airbag that has deployed. And airbags that do deploy can cause facial trauma. So patients may have broken noses, may have facial lacerations due to a variety of things. However, those injuries should not be incapacitating or life-threatening. Gasoline and electrical hybrid vehicles. Hybrid vehicles have two electrical systems. They've got a standard 12-volt system, and then they may contain a high voltage system as well, which may contain 500 volts of DC current, and it's typically coated with an orange color. As far as gasoline and electrical hybrid vehicles, identify the vehicle is a hybrid, stabilize the vehicle, gain access to the passenger compartment, shift the gear to park, turn off the ignition, place the key on the dash, leave the dash, verifying that the dash light indicating energized hybrid system has gone out, and then shut down the vehicle's 12-volt electrical system at the battery. Okay, and here's the in the trunk of this particular vehicle, the wiring that goes to a high-capacity battery. The emergency procedures at a fire are just normal firefighting procedures. If the fire originated in the battery pack or the wiring, we're dealing with high voltage concerns in hybrid cars and melted batteries. As far as the emergency procedures at a crash incident, the vehicle needs to be stabilized. May consider something like lockout, tagout, or some other sort of procedure to check and double check safety before gaining access and before stabilizing the vehicle. Some of the EMS responder safety at vehicle crash scenes are going to include: you may be dealing with an environmental hazard, you may be dealing with an incident scene hazard, and then hazards with the vehicles themselves. Your environmental hazards certainly could be extreme temperatures. Your incident scene hazards could be whatever the vehicles were carrying, and then your vehicle hazards would include spilled gasoline, kerosene, diesel fuel, battery acid, those sort of things that you could be exposed to as a result of a crash. When working in or near moving traffic, there's a lot of emergency workers that are killed every year. We see all the videos on TV all the time of cars that become mesmerized by the lights that are flashing and veer right into the emergency vehicle, and if you're anywhere near there, you certainly could get killed. So sometimes people will use the vehicle as initial traffic control, but then as other vehicles respond, protect and secure that emergency vehicle, or block other oncoming traffic, so that they're not likely to strike your vehicle. We saw this in Waterloo, where the fire department would respond with a big tanker truck, and the tanker truck would be the last truck in the line, so that if people came up and they were mesmerized by the lights, they would run right into the tanker truck, which, when loaded with water, essentially doesn't go anywhere. As far as let's see, as far as trying to look at what this bullet point's trying to say here. Prompt traffic control, safe parking. I told you about Waterloo Fire. High visibility marking on the vehicles, particularly at night or in dense fog. Remember, you may be down to one lane of travel, and what I'm seeing a lot of law enforcement agencies do are they're blocking the section, where they block the highway for 1 mile on either side and require people to drive around the section, so they avoid going through the incident site at all. You have to wear, it's a OSHA mandate, you have to wear high visibility vests or jackets whenever dealing with a motor vehicle accident on at the scene where you're on a road or highway. Okay? So here are just a couple examples of, they've got the vehicle parked. Hard to say whether the vehicle is parked ahead or behind the other rescue vehicles in the bottom right hand quarter, but with the fire truck there, or the rescue truck there, it looks like they're blocking 2 lanes of traffic and have cones set up, so as people fly down the interstate, they're not likely to interfere with anything that's going on with the accident up ahead. You may have to establish a hot zone. Hot zone is the highest risk closest to the crash vehicles. If there's fuel that's spilled, there's a potential for fire. You should be 50 feet evacuated in all directions from the hot zone. If fire is a potential, then you should be 100 feet in all directions from the hot zone. And if you're dealing with a hazmat scene, you should be 2,000 feet to start with until you identify your parameters. If you've got wires down, look at the pole beyond the damaged pole and see if it's upright, intact, if the wires are attached to it, because that may be an indication that you're dealing with a live line. Know when you need standby. Know when you have fluids leaking from motor vehicles, that those are potentially hazardous, as well as the likelihood of explosion certainly could occur, especially if we're dealing with gasoline. So large amounts of gasoline or diesel fuel or alternative fuels or magnesium, when it mixes with water, certainly can generate a tremendous amount of heat as well. So these are things that you need to keep in mind to keep the scene safe. Wires that are down, we already mentioned that already, but energy can travel through the ground. 19,900 volts is common in a residential area. The amperage is flowing through the object, and so amperage is what we look at most. You know, if it's over a certain amperage, it's likely to be more damaging than volts. So amps is what we look at for damage more so than volts. You want to establish your hot zone. You want to ensure that you've de-energized the electrical down power line before entering. I'm not quite sure what they mean by a duck walk approach to the scene. whether you're waddling or you have a good stride from shoulder to shoulder and you're just walking very deliberately like a duck, um, with your eyes open and trying to determine the hazard. As far as vehicle crash, rescue, and extrication concerned, there are different phases to the extrication. Phase 1, these are the activities of the initial responders. They'll set the stage for the incident by identifying arrival and safe parking, by conducting a scene size-up, by establishing incident command, by selecting a vehicle stabilization, by wearing airbags or scanning for airbags, shutting down electrical systems, controlling spilled liquids or hazards at the scene, and gaining initial access to the patient. And here's just another example of care that is being provided. Stage 2 is disentanglement, and this requires a person to open the doors. So usually both doors end up coming off so that they can access the patient to get them out. Phase 3 is to roll the roof back, and that's going to provide the greatest access to the patient. Phase 4 is movement of the dashboard and the instrument panel and the firewall off the patient. Surface water rescue certainly can pose a hazard. You can have moving water, and moving water as it drops over a ledge creates what's called a drowning machine. It's also called a hydraulic. When water moves over a uniform obstruction to flow, it may develop a low head dam, causing the current in that backflow trap to suck objects, people, whatever, into that, and the current may be significant enough not to be able to swim out of there. Strainers are formed by objects or structure in the waterways that allow water to flow through but catch large objects. Strainers include trees, fences, grates, dam intakes, and the current will hold people that have drowned against a strainer for obviously long periods of time. A foot or extremity pin, the only way to rescue is upstream. If an extremity is caught, loosen the way it was caught. Never wade in streams deeper than the mid-tibia, because you don't know if there's going to be a drop-off or step-off or that sort of thing. Dams and hydroelectric intakes. You look at Gavin's Point Dam in South Dakota. I don't know what dams are close to the Council Bluffs area, but upstream side of the dam, you could be sucked into the intake or spillway, which is often invisible because of the water level. Now, downstream is on the bottom side of the spillway, and that's where you can end up with hydraulics as the water is pumped through those hydroelectric generators and pushed back up to the surface. Flat water, slow moving or still, whenever around water, you need to wear PFDs, personal flotation devices. Over half the people who drown have ingested alcohol, so that's a problem associated with drowning. The vast majority of people who drown cannot swim and had no intention of being in the water. If the water temperature is less than 98, which is all water in Iowa, it's going to cause hypothermia. Remember that water causes heat loss 20 times faster than air does. So if a person falls into really, really cold water, the mammalian diving reflex will allow them to stay submerged under the water for long periods of time. that period of time seems to be about an hour. But for that to work, the water has to be really, really, really ice cold, and the person has to cool down really, really, really fast. And if that doesn't happen, then that mammalian diving reflex doesn't quite work. Things that determine whether you're going to survive a water temperature and drowning: age, submersion length of time, the presence of trauma, contaminants inhaled from the water, your posture in the water, and your overall physical condition and health. How to survive, or not how to survive, survivability. The chance that these water rescues, that these patients will survive, if it's less than an hour, we consider them salvageable. So we treat our hypothermic victims as salvageable until we can warm them up. So they must be rewarmed and assessed before death is confirmed. So follow the ACLS algorithm on hypothermia. One way to prevent heat loss while in the water is to put yourself in the HELP position. The HELP position stands for Heat Escape Lessening Position. And there's an illustration of the HELP position. The knees are flexed, everything is drawn inward towards the core, the arms are pressed tightly against the chest, and this helps you conserve heat and energy when you find yourself in water. As far as splinting or providing spinal stabilization while the patient is in the water, you want to approach the victims from the side, move the victim's arm over their head, hold the victim's head in place, and use the victim's arms as your splint. Hold their elbows up against both sides of their head, and use that as a splint. If the patient is face down, you're going to rotate the victim toward the rescuer to a face-up position. You're going to open their airway and then maintain position until the cervical collar is applied. Now, there are certain situations where you're going to think a cervical collar would be necessary. Not on all patients. If you know that this patient, slipped off the dock, fell into the water, had a drowning event, there's no need to immobilize C-collar, board, all that other stuff, unless you're using a board to get them out of the water. But if you're dealing with a diving accident, you're dealing with a really fast water slide, those sort of situations, there might be some cervical spine trauma. Okay, cervical collar application. You've got the one rescuer, remember again, who's got the elbows pinned against the head. You've slid a board up underneath him. Or a second rescuer can size the collar, put the collar on the neck, and then put the victim's arms, or the patient's arms, back to where they were to stabilize the head with the collar on. You can submerge a board under a victim and help float the board up to the victim, and then float the victim to the safety where you can strap them in and then pick them up out of the water, pick them up and put them into a boat, all that sort of stuff. And when you're taking a patient out of the water, obviously extricate them head first, so that they're not their feet don't come out of the water first, and they're tipped upside down, allowing water, or allowing their blood to rush to their head, that sort of thing. Avoid extrication through surf to prevent capsizing, and when they talk about maintaining airway management during extrication, granted, if the patient is unresponsive, you've got to keep their airway open just like you would any other sort of rescue. But particularly in cases of drowning, we want to ventilate these patients as soon as we possibly can. So that would require us to start performing ventilation while the patient is still in the water while we're trying to extricate him. Some basic principles of water rescue include never underestimate the power of moving water. Do not enter water without highly specialized training and the right equipment. Your priorities are always self-rescue first, fellow rescuers second, the patient last. And anytime you're around water, you should be wearing a PFD. Some basic water rescue model. We remember things like talk, reach, throw, and row. Talk to your patient. Coach them onto where they can swim to safety. If you can't, they don't understand, they're not listening, you could get something like a long stick or a net and try to reach them. If you don't have anything like that, you can throw something floatable at them so that they can get a hold of it, and you can throw something floatable so that they can get a hold of it. But if a person is drowning, let's say that they're actually drowning and you're trying to throw something to them, you need to hit them with it, because oftentimes they pop up out of the water, they have not wiped the water away from their eyes, so they aren't able to see, they're slapping the water, they're trying to stay above the water, their neck may be hyperextended as they're trying to open their airway to its max in order to get air into their lungs, and you need to hit them with whatever it is you're throwing at them, a tow rope, a cooler, a PFD, and when they feel that hit them, they might reach out and grab for it. And the last thing that you would consider would be to get into a boat and take it to the patient. Okay? You need a properly fitting PFD if you're going to be around water rescue. You're going to need a helmet in case you fall in, bump your head. You're going to need a knife to cut yourself out if you get entangled, a whistle to help identify your location, and then proper suiting to keep you warm. You're going to need something to float for the victim. You may need immobilization and extrication equipment depending upon what you're doing to get the victim out of the water. You may need thermal protection, especially after you get them out of the water. If they've been in there any length of time and the water's cold, they can be hypothermic. You may need resuscitation equipment, not so much in the water other than perhaps a pocket mask or a face shield if you have to begin rescue breathing on somebody who is not breathing. And then equipment to get them from the water back to the shore. If you're going to do, if you're in need of rescue, you find yourself in water and you had no intention of being there, whether you're fully clothed or in a swimsuit, attempt to cover your mouth and nose as you fall into the water. Sometimes falling into the water, if it's really cold, the reflex to go quickly, if you fall into the water and you do that, you can get some water in your larynx, cause a vasospasm or a laryngeal spasm. The larynx will clamp shut, you become hypoxic, anoxic, and slip under the water. So cover your mouth and nose if you know you're going into water. Protect your head and keep your face out of the water. We are all buoyant. There are some people that say, nope, they sink right to the bottom of the lake when they get in the water, and that might be because of them panicking. Everybody is buoyant. We will float. We've got two great big floats inside our chest. If we keep those full, much like a fish in their floats, we can regulate our buoyancy. If you're in flat water, assume the help position to maintain heat until you can be rescued. If you're in moving water, don't attempt to stand up in moving water. Float on your back with your feet pointing downstream and your head pointing toward the nearest shore at a 45-degree angle. Because at some point you may reach current where it's not as brisk and you can roll over onto your belly and swim towards the shore. O2 deficient environments and confined spaces are hazardous atmospheres as well. Confined space requirements. Confined spaces, they have to be large enough in order to get a body into them to perform work. So there are tunnels, there are crawl spaces, whatever you want to call them. They're confined, but they're large enough that you can get a body in there to work on whatever it is that's in there. But when you get in there, you have a limited and restricted means of entry or exit. It is not designed for continuous occupancy. It's an environment where there may not be a lot of oxygen, and there may in fact be gases like methane. You typically have to have a permit to enter a confined space because of the hazardous atmosphere. The confined space may contain material with potential for engulfing the person who goes in there. You could become trapped and asphyxiated, especially if the walls cave in, or a floor that has slopes. And the confined space may contain other recognized serious safety or health hazards as well. Some confined safe hazards include hazardous atmospheres, poisonous gases, fire and explosion, and engulfment. Machinery entrapment is considered a confined space. Electricity you might find in confined space. Structural hazards are collapse, like a trench collapse. And then fall hazards if you're dealing with that sloped floor. Steps for safe entry into a confined space: monitor the environment, make sure that they're doing atmospheric monitoring and that there is oxygen in the space. Lockout, tag out, all power, so there's no chance of being electrocuted in the space. And then using some sort of buddy system to lower and retrieve the rescuer and the victim. Now, this isn't something that, as a paramedic, you're going to be expected to do. These are techniques and steps that people trained specifically in confined space entry will do. As far as hazardous atmospheres, the first actions of you as an EMS personnel is to establish a safe perimeter, restrict any additional entry, assist with remote retrieval, determine the type of work being done and when the accident happened, the number of workers inside, how many victims are you going to have, do you need additional resources, help others put on their personal protective equipment prior to going in, and assure that you have those buddy system retrieval systems in place. As far as hazards that the first responder might deal with as well, they may include contaminants, and you need to determine the type of hazards, the extent of the hazards, and what sort of possible problems the hazard created. Rescue from trench and cave-ins. These do occur. This occurs when the lip of or sides of a cave cave in, or trench, I should say cave. When the lip of or the sides of the trench cave in and fall upon the person that's inside there. The walls may shear away and fall inside. If the spoil pile or the loose stuff is too close to the edge, it can cause a collapse of the sides, and all that stuff can fall in on top of who's ever in the trench. Some things that increase a trench cave-in: previously disturbed soil, intersecting trenches, ground vibrations from trucks and machinery, dirt piled too close to the edge of the trench, and water seepage in the walls of the trench. Your initial response, do understand that if there's been one collapse, there always is a potential for a secondary collapse. You want to secure the scene, set up incident command, secure the perimeter, and only people with trench rescue training should be allowed within the perimeter. Some things as a paramedic that you need to consider with trench rescue is the potential for crush injury. If a patient is being pinned into a trench, surrounded by lots of dirt, which weighs a lot, they may be suffering crush injuries. And with crush injuries, you cause muscle damage. When you damage the muscle, you cause the release of myoglobin, so they can get myoglobinemia, lots of myoglobin in the blood, and in addition to that, it's also called rhabdomyolysis. With rhabdo, you're going to get potassium shifts, lots of fluid loss, as well as all this myoglobin, because when muscle is damaged, it will take on lots of fluid, decreasing the amount of fluid you have for other tissues. They're in cold ground, so chances are if they're in there for a long period of time, they're going to need warm IVs. They're going to need warm air pumped into the trench. As far as hazardous terrain goes, there's a variety of different terrains that people may have to overcome as part of rescue. You can have steep slopes, low-angle terrains, or a low-angle rescue environment. Steep slopes could be as simple as a ditch, a very steep ditch that you have to go down into where a car is and retrieve a patient and bring them back up out of that steep ditch. You can have high-angle rescues, high-angle vertical rescues, as in the case of silos, grain bins, and of course now these wind generators. And you can have flat terrains with obstruction as well. Patient access to hazardous terrain, particularly when we're talking about high-angle rescue, requires some skills like belaying, rappelling, a high-angle litter for evacuation. So again, this is something that is carried out by somebody who has training in high-angle rescue, that is very comfortable with rappelling, that is very comfortable with belaying and braking as they rappel, is very comfortable, putting a patient in a Stokes basket and then lowering the patient down with ropes. Again, Stokes baskets are probably the more common basket that they will use for hazardous terrain rescue. There are metal baskets, there are plastic baskets. We see these used sometimes for water rescue as well. Float aboard with a patient on it inside this, attached to a jet ski, and pull the patient to safety. You can have flexible litters that wrap closely around the patient. They're a little easier to work with in confined spaces, and they become more rigid when you conform them around the patient. As far as packaging goes, you want to protect the patient from physical and environmental hazards, so you want to make sure that they're warm and they're kept dry, and their faces and airway is accessible. You want to make the patient comfortable. You want to physically strap them into the litter, but allow access for monitoring blood pressure, pulses, airway. Some litters have patient restraint systems, and if you don't, then you just use an improvised patient tie-in. So here's an example of perhaps a way that you might tie a patient in to a litter to protect them from sliding out. There are litter shields, face shields that go over the patient, goggles and helmet that the patient could be wearing to protect them as well. As far as starting IVs, you might I'm not sure what they mean by a pressure infuser. I know what a pressure infuser bag is, but I'm not tying in how you'd have to use a pressure bag. You can use a BP cuff as a pressure bag. Perhaps running fluid under pressure would prevent some sort of air embolism. If you're dealing with litter rescue in ice cold water, then obviously your IV fluids are going to freeze and become cold as well. But the bottom line is when you're putting patient in a litter, make sure that they are secure. They can't move up, down, left, right, or slide out, but that you still have access to monitor things like pulses, their airway, and perhaps a blood pressure. Airway management. You can roll a person in a litter in case the patient starts to vomiting. There's usually room at the head of the litter to perhaps at least keep a hand-operated suction unit, if not a smaller suction unit. You can roll them up into the lateral recumbent position if they're on a vacuum mattress. As with any board, any litter, anything hard that they're going to be laying on, you want to make sure and pad those areas where they could end up developing pressure sores later. Your patient restraint, as we've already mentioned, is going to prevent the patient from sliding. You can use a KED to help secure a patient in a litter. There's also something called the Oregon spine splint. You can use vacuum mattresses. All those things can go inside the litter. Here is some sort of wrap that you could put the patient in using blankets to protect them from the wind, the cold, the rain. You've got a waterproof and windproof outer layer, but you have access to the patient's sides at all times. The litter underside should be solid so that it protects protruding objects from poking up through the litter as you're carrying it or sliding it across the surface. You need to pad the bottom and pad the hollow spaces to prevent the patient from moving around. A patient in a litter can have rigid splints, can have a Sager splint, a KED. So any sort of other splints that you might apply, you can apply to a patient that's inside a litter like a Stokes basket. However, it might be a little overkill because if you've got them immobilized per se on a board in a litter, is there really a need to put on those splints? And depending on their overall condition, you may keep them on scene too long. As far as packaging and securing the litter, there are litter slings, little wheels that can be used to help move the patient that's in a litter. This happens to be a belay that a person would use to run rope through to help break and lower devices during high angle rescue. So here they're showing, a single repeller secured. Here they're showing two people lowering the repeller and the basket down, and a secondary group anchored off in two other locations to help stabilize and lower as well. Low angle and high angle evacuation. This is just supposed to illustrate the hauling and moving of equipment. And you see the basket there on the bottom being pulled up in order to bring equipment up to where you are. Here they're talking about using some sort of device on the bumper of a rescue truck to pull a victim in a litter up perhaps a steep embankment. Low angle and high angle evacuation, as we already showed you, requires, or you may have to use a belay, and if you're not familiar with how to use it, then of course it's essentially useless. If you're not familiar with the equipment necessary for these high and low angle evacuations, failure on your part could be catastrophic and even cause severe injury or death. Um, you can use aerial apparatus as well, a tower ladder or bucket trucks uh, for low angle and high angle evacuations. You can use helicopters in hazardous terrain rescue, but again, you must have to have knowledge of how to do that. You must have a precise location for the pilot. All the ground safety needs to occur as well, as far as keeping clear of the rear rotors. Approach the helicopter only when directed by the pilot. Buckle and unbuckle your seatbelt when directed. Wear eye protection. Don't throw objects to or from the helicopter. Don't smoke. Keep clear of controls. Hold loose objects securely. Stay alert for hazards, towers, lines, trees. Avoid unnecessary talk with the flight crew. Keep the seatbelt and shoulder harness fastened until you're instructed by the pilot to unbuckle. Helicopters can hover over an injured victim, hover over an injured victim. Um, they can do short hauls, sling loads, hoist rescues, are all something that could occur with a helicopter, because then again you would need to be familiar with those type of rescue operations. Okay, so with that, that ends chapter 63. I will talk to you soon. If you have any questions, you do know how to get hold of me.